Hello, everybody. Can you all hear me? Okay. Great. How's your day so far? Not so good? How's your day so far? Okay, it'll be a lot better after this session, trust me. Okay, you'll all go with a lot of energy when you walk out of this room. You know what? I'll do a demo today, and this demo will be a unique demo because I'll have each one of you participate in that demo. How about that? Right? So let's see how it goes. Okay, wish me luck, and also I'll wish you luck. Let's see who is going to win. I'll have a nice thing here. I'll show you what it is. Okay, my name is Roshan Kumar. I work for Redis Labs. How many of you know Redis? Great. How many of you know Redis Labs? Okay. So Redis Labs is the company that sponsors the open source Redis project. We also have Redis Enterprise, which is the commercial version of Redis. It is built on top of open source Redis, but it is mainly catered for enterprises where you can manage all your Redis instances. Suppose your Redis data grows from few megabytes to a few terabytes. You'll end up having so many Redis instances, right? So how are you going to manage? And if you're using Redis streams that I'm going to talk, you need high availability and you don't want to lose data. Now, how are you going to achieve that? That's what you'll get with Redis Enterprise. But I'm not talking about Redis Enterprise today. I'll just talk about Redis, which is open source Redis, and I'll show how you can integrate that with Spark in the context of structured streaming, right? So my talk is about this. It's a very simple thing. You are collecting data on a continuous basis. And there are many use cases that follow this. It could be IoT, it could just be the click tracker, or it can be messages. There are many, many use cases where you capture data and you need to process that data in real time. How are you going to do that? And it's not just how you are going to do that. It is how you are going to do that at scale and in production. So that is the topic today, right? Okay, so this is where I'm going to start a demo. And this is the demo where I'll have each one of you participate in, right? Are you ready for that? Okay, there are still people settling down. So there is a demo here. So you should settle down really fast so that we can start the demo. Okay, it's not a terrific demo. It's an easy demo. The idea is this. I'll take you to this small site. You have to open up your cell phones, and I'll tell you what that site is. And you have to vote for the best dog. And you keep on voting all through the session, and we'll see which dog wins. We'll keep a track of that. We'll see how it goes. And it's very easy. I'll show you here what I'm going to do. So I have this here. I have already loaded up here. Let's say I like this dog. I'll just vote for it. And what's happening in the back end is I'm collecting everything in Redis streams, and I have connected Spark structured stream to Redis streams. And then, finally, I can run a Spark query to see how it goes. You can all see this, right? Oops, you know what? I need to run this again. Okay, let me reload this. And then, let me do this. And then, okay, this is still picking it up. All right. So I had run it a few times before. So I'm seeing there are a lot of people already doing it. Okay, so there are already people doing it. So this goes on and on and on. Right? So this is the site. If you can go to bit.ly/Spark Redis, if you can load that. How many of you think the first dog is going to win? No? Nobody? How many of you think second dog is going to win? Okay, there are a few. How many of you think the third one is going to win? Oh, a lot. Okay, let's see. I will vote for the underdog. So I'll vote for the second dog. And so far, let's see how we are doing. All right. The third one is winning, but okay, all those who raised your hands for the second dog, go on, click on the second dog as much as you can. Right? So that's what. will do. So what's happening in the background? This is what we are doing. But in the background, this is what is happening. I'm collecting all click data, and there is a data ingest solution. I'm just trying to divide this into functional blocks. And this data ingest solution, it records all the clicks. So all the clicks that you're doing now, go on doing it, don't stop. This will go on for the next 40 minutes. And then there is a data processing engine, and this is Spark in my case. And this data processing engine, it connects to Redis streams, and it gets all the data. It doesn't lose any data, so it gets all the data. And then finally, I have a data query solution, and here I'm using Spark SQL, right? So it's a combination of Redis streams and Spark. That's what is happening here. And again, it's the same thing here, and I'm just explaining what these functional blocks are built on. And for this app that you're clicking on right now, I developed that on Node.js. It's a very simple stack. I just use Express, and then there is a Node Redis library, so I'm just using that. And then any click you do, I'm pushing that to Redis stream, and Redis stream can scale. It can take millions of writes per second on a single machine. So whatever we have here in this room, you just multiply that by 1 million or almost 1 million, maybe 100,000. You can still have Redis capture all that data. So that's how you can scale with Redis, right? And then structured streaming will get all this data in batches, in micro batches, and let's see that a bit. So you can see this here. So this is where I'm getting structured streaming, and also I'm seeing some undefined here. That's fine. So let's see what's happening here. So there is one undefined. I'll explain to you what this is. So now the second dog is winning. Yay! So who are those who raised your hand for second dog? Yeah, there are a few. Okay, come on, raise your hand more. Most likely you will win. Let's see. Okay, and those who are voting for the third dog, keep doing that. Let's see what happens. All right? Okay, the second one is winning. The first one is also catching up. Wow. And those who are doing it for the third one, you may be in trouble. Okay. All right. Now let's go back to all the technical stuff. Now, data ingest solution. So since I come from Redis Labs, I'll spend significant amount of time talking about data ingest because that's my vested interest here. I'm talking about Redis Labs. And how many of you have heard of Redis streams? Oh, okay. How many of you know Kafka? Oh, there are a lot more. Okay. Okay. Redis streams is Kafka killer. Well, somebody was asking me, how is Redis streams different from Kafka? It's like this. Kafka is like a big rig truck, and Redis streams is like a Ferrari. Redis streams, Redis is an in-memory database. It's extremely fast. It's lightweight, very simple. If you have downloaded and installed Redis as a NoSQL in-memory solution or database, some people don't call it database, whatever your view is, it takes 2 or 3 seconds to download and install. And how many, you can also, how many of you use Docker? Oh, okay, a lot. How many Docker pulls have happened on Redis so far? It's 1.5 billion. So this, Redis is the most pulled Docker instance, Docker container. Or maybe now Mongo is neck to neck. But for a long time, Redis was number one. And Redis was the first Docker container to reach 1 million pulls on Docker Hub. So it is very easy to use, very easy to configure, very easy to manage. You don't need Zookeeper. I don't know if anybody attended the previous session. Ted from previous session talked about Kafka and downtimes. Businesses, they could not get the Kafka instances back. And there were problems with Zookeeper. There was data loss. You don't run into any of these issues with Redis. But with that said, Kafka is good for some other use cases where you have maybe a lot of cold data, where you don't need to You just need to store it, right? Cold data. So you're writing data to disk. So maybe that's where Kafka is a good use case. But for a streaming database, it's a transient. You're storing data as a transient store, right? So you'll need to consider whether to use Redis streams or Kafka. Okay, talking about Redis streams, it was introduced to Redis in October 2018, so it's not even a year. The GA release, I mean. But the experimental release was done a year before. It was announced in 2017. So it took about a year to develop and test everything and do a GA release. And it's a very stable release, and we have many customers who are using Redis streams. And if anybody is using Redis, you're familiar with PubSub. And we are also seeing that more and more people are moving away from PubSub and going Redis streams way. Right? Okay. From a very simple point of view, this is how Redis streams looks like. It is a data structure that connects a producer and a consumer. But in reality, you'll have more producers and more consumers, right? And it can scale. You can have 10,000 consumers or 10,000 producers. That's not a problem at all. Right? And then those who are familiar with PubSub, lists, and sorted sets, these are all different data structures and capabilities in Redis. Redis streams does all these things a lot better. For example, in PubSub, you publish something to a channel, and if you have subscribers who subscribe to that channel, they receive all those messages. But if the channel goes down, all those receivers, or if the receiver loses connection, they won't get any of those messages. So there is no persistence. But with Redis streams, you're guaranteed of persistence, and you don't lose data. Now, lists have their own advantages and their own disadvantages. If you have used list data structure, it's like a linked list. If you have 1,000 consumers, you'll need to have 1,000 separate linked lists for each consumer. So it's not a good idea if you have a lot of data. Sorted sets, you have to pull data. There is no blocking calls. So you cannot do asynchronous data transfer between producer and consumer. So these are all limitations in traditional Redis data structures, and we fixed all that in Redis streams. So Redis streams is a combination of PubSub, lists, and sorted sets, and it also does a lot of things. It supports lifecycle for consuming data. You can scale up. It has something called consumer groups, so you can have multiple consumers who belong to a group. And if one consumer goes down while processing that data, you can have another consumer claim all the data. And there are a lot of things so that you maintain data safety. And it's like transaction-like data safety. That's what I call. And also, it's extremely fast. It runs at Redis speed. If anybody has used Redis, you know what I'm talking about. It's extremely fast. Right? Okay, now Redis streams benefits. First of all, asynchronous communication between multiple producers and multiple consumers. And your consumers can be anything. You can have messaging, or you can have analytics, or you can just have a data backup service as a consumer, right? So your consumers may have different requirements. They may run at different speeds, different latency requirements, but it's perfectly fine with Redis streams. And the other thing is scaling out. If your producer produces a lot faster than one of your consumers can consume, let's say image processing. In this example, the producer is producing 500 images per second, but your consumer can process, let's say, 100 images per second. You need 5 consumers, right? So what you can do is you can create a consumer group and have 5 consumers. It's like scaling out. And each consumer will get an exclusive set of images. So there won't be any duplication. It's automatically deduped, and each consumer will get a separate data set, and it's all done in real time. Right? And also, you can simplify. Now, this is a complex scenario where you have a lot of producers, a lot of consumers, and many different types of consumers who have very different needs. You can have consumers that do look-back queries that are not listening to Redis streams for asynchronous messaging. They can just do look-back every day or every hour or every week, whatever. And you can keep data forever in Redis streams. It's not like Amazon Kinesis where you can keep data for a day or less than a day, or Kafka where you can keep up to a week or 3 days or a week, depending on what service you have. Here you can keep data forever. You don't need to delete data, right? All right, for data ingest, it's a very simple solution. All you have to do is run a command called xadd. So that's what is here. Is it visible? Xadd. And I just need to give a name to the stream. I'm calling it clickstream. So that's what I'm doing here in my example. And when I do xadd clickstream, and for each image, I'm sending the image ID. And that goes in as a stream data, right? So let me show you one more thing here. Now, if I go here, so OK, it's still consuming. So I can do xlen. So far, this room has contributed to 77,236 clicks. And every click is recorded. So it's going on. It's still going on. Right? So you can see this using xlen. And also, I can trim this. I don't want to trim it right now, but I can trim my Redis stream to whatever I want. And also, while I do xadd, I can say, let the maximum size of this stream be so much. So there are many options for you. Right? And let's see how we are doing here. OK, somebody has added image 4, which is not a problem at all. Somebody has hacked the system, which is really nice. And what is happening here, I can show it a bit later. There is a hash table, and that hash table has all this data. So I have image 1, 2, and 3, and number 3 is winning. What happened to the second dog? Guys, everybody who raised hand for the second dog, come on, you need to push hard. OK, let's see. Let's keep going. Right? All right, what else is happening here? Now, we saw data ingest. I'm collecting all data in Redis stream. Now, what's happening in data processing is I'm using structured streaming. I'm assuming everybody here knows structured streaming. Is there anybody who doesn't know structured streaming? OK, so everybody knows. OK, I don't need to talk anymore. I can just walk away. But I'll give a quick introduction for those who are new to structured streaming. This is a definition which I could not understand. So if you can understand, please help me understand. But in a very easy way, this is what it is. Let's say you have a source for data. In this case, it is Redis stream. All your structured stream does is it gets data. It pulls data in micro batches. And then it converts those micro batches into data frames. So it uses the data frames API. So that's cool. If you have used data frames, you know what I'm talking about. Data frames is cool. It gives you a view of a table, right? So you're collecting all the data in micro batches, and each micro batch is now like a table. Now, once that becomes a table, you can run a query on that table, on that micro batch. So that's what I'm doing here. So you can have a query which can be a selection query or a filtering query or anything. So in my example, in this example that I'm showing you now, I'm doing an aggregation query because I'm counting how many clicks are happening on each image. That's it. So I'm running an aggregation query. But if you want to run a filtering query, perfectly fine. So you can run many queries on your micro batches. And after you do that, you can dump it to an output sink. So you have source, you have sink, and in between, you're getting micro batches, and you're operating on those micro batches as if they're all data frames, and you're running queries. So that's what is structured streaming. And it does many other things, but from a basic point of view, that's what it is. Right? It's simple. Okay. Now, how can you have Spark connect to Redis stream? I'm sure you have been asking about this. Many of you have thought about this. So there is a library called Spark Redis Library. And guess who sponsors this open source project, Spark Redis Library? It's Redis Labs, right? So Redis Labs sponsors Spark Redis project, and this is available on GitHub. So you can just Google Spark Redis Library, and you will see. It is all written in Scala, and it is compatible with Spark 2.3 and higher. It's also compatible with 2.4. I'm running on 2.4, so it is compatible with 2.4. And it supports RDD, data frames, structured streaming, everything, all cool stuff. And you can use this library to connect your Spark engine to Redis as a source. So you can make Redis your data source. And when I say Redis, it's not just limited to Redis streams. You can even have lists or any other data structures in Redis that become source for your computation. But streams is the most logical way to collect data and get them into structured streaming. But you can use any data source. So with Spark Redis library, you can use Redis as a source. And you can also use Redis as your sink. So you get double advantage here. You can read from Redis, do all computation, and write back to Redis if you want to. And that's what I'm doing here in my demo. But it's not necessary that you use Redis as a sink unless you are using it for something else, right? But this is just an example. Or you can just use Spark Redis library as a data sink that puts all the data back to Redis. It's also possible. You may have some use case. All right, how do you do this? How do you use Redis as a data source? There are 4 steps. The first step is you connect to the Redis instance. You open a Spark session, and you pass all the parameters to connect to Redis. It's very easy. It's all well documented on Spark Redis library. Second thing is you need to map your data frames to Redis stream data structure, the names that you have used in Redis streams data structure. For example, in my demo, I'm calling the Redis stream as clickstream. So that's the name I gave. You can give whatever name you want. And I'm mapping that here in this definition. And then at the same time, in Redis streams, you can have key value. You can just go on adding all key values, key value pairs. And I'm using the key IMG, and that's what I'm defining here. I'm just using IMG as the key. That's what I'm saying here. And finally, this is my query. I have to define my query. I have to create that query object. And finally, I have to run that query. That's all. So it is so simple. So just 4 steps. And that's what makes structured streaming so easy, simple, and it's so easy to use. Okay, now Redis as an output sink. Instead of writing to Hive or some file or anything, I'm just, for the sake of this demo, I'm writing all the data back to Redis. And how I'm doing this is, okay, I have these micro batches. I'm aggregating all the data. And then that aggregated data, I'm putting them back to Redis in a data structure called hash. If you're familiar with Redis, you know what I'm talking about. Hash is just like a map. It has all key value pairs. And I'll show you here in the example. So here, if I do, let's say, scan 0 clicks. Oops. I'll just do keys. Okay, there are so many images. I see so many people hacking this into so many things. So you have all these clicks, right? So these are all hashes. You have image 1, 2, 3, 4. And if I run a query here, now you will see image Redis, image 5, clicks Kafka, clicks image 3, and so on. Okay? So let's see this. So these are all you see here. So somebody has been playing around, which is good. So it is helping me with my demo. That's great. And you can see, you can run a command called get all clicks image underscore 1, right? So I have image 1, count, and this is the count. And if I do for, let's say, and I can even do this way. I can do set, and key I'll do clicks, and then I'll do Kafka, and then field, I'll say count, I'll make it 0, right? So let's see how much I have for Kafka here. I have 0. So that's how you can use Redis as a sink, right? Any question? If you have any question, you can speak on the mic. I can answer any question if you have, but it is as simple as that. And then after this, data querying, it is quite easy. What I'm doing here is I'm using Spark SQL, and I'm using the same library, Spark Redis library, and I'm using hash, or I'm mapping Redis's hash data structure to a data frame, and I'm saying this hash starts with clicks. So any hash that has a name that starts with clicks belongs to a table called clicks. And if you see this, when you see this get all, I have key called img, and I have another key called count. And all of these hashes, they have the same structure. They have the same key and the same set of keys, but the values will be different. So when they have the same keys, I'm just calling it as a column. So here, for example, img is a column, and that's a key in the data structure. Now count is a column, and that's a key in this data structure. And all hash objects here, they all have the same structure. So I'm doing that mapping here, right? And then finally, it's the same thing. You need to initialize, connect to your Redis server, and then you need to create a table if it doesn't exist. And in that definition, you are telling Spark SQL, hey, create a table with this name and map, and you're defining all the maps. And map this hash table that starts with name clicks to a table called clicks, and then it automatically creates a table. And then internally, you're saying use img as a string and count as an integer. So it expects that hash has these keys. And then you run the query, which is pretty straightforward. And you can even plug in Tableau or anything if you have Tableau already. And you can use any ODBC connector and connect here. Right? OK, for recap, this is what we did. And let's see what's going on right now. What's the final score? I hope the second dog has caught up. Oops. OK, second dog is so much. Oh, for 3 and 4, they are winning even more. So somebody is sending more. Somebody has written a loop program that has that's just going on. That's good. That's nice. Very nice. And let's see xlen click stream. So you can see this. Oops. It has 162,000 plus clicks collected so far. So this can go on. It can go on and on and on. And as I said earlier, the scale here we have in this room is small compared to what Redis can do. You just multiply this by 100,000, and Redis, the same instance of Redis can handle that 100,000 clicks. And I'm running Redis on Redis Cloud, so it can automatically scale. It's a Redis Cloud instance. I'm not running Redis on my laptop. So it can easily handle 1 million more people doing the same stuff. Right? And if you have any questions, I can take questions, but this is the summary of what I just described. we collected all the clicks, and there is a data ingest solution. There is a structured stream processing engine, and then I use Spark SQL. And to connect Spark and Redis, I used Spark Redis library. So that is the gist. That's the summary of this presentation. Now, how many of you know Redis streams? Yay, so that was my intention. So that's good. Right? How many of you say Redis streams will kill Kafka?
All right, guys, if you have any questions, please come up to the mic. And before folks start pouring out, please rate the session as well. So it's on the app. You just click the button, scroll down, click another button, rate it. But if you have any questions, please come up to the mic.
Hello. We use Redis heavily, so we are not aware of Redis streams.
Okay.
So the feedback we have is Redis is if crashes, we lose the data. That's why we also use Kafka for our stuff. So what do you suggest having being in a Redis streams?
Yeah, that's a very good question. If you configure Redis properly, you won't lose data. There are a couple of things you can do. One is you can enable persistence. Second thing is you can have master replica, and you don't need to persist data in master, so that master is always doing in-memory processing.
So the interval to persist, like is whatever the 15 minutes or 10 minutes, do we lose the data of that?
Oh, okay, there are different types of persisting data. One is something called append-only file. In append-only file, you have two options. You can sync for every write, or you can sync for every second. You can do fsync every second. And the third option is you can do snapshotting. So that's what you're doing, which is every few minutes. But there are other ways to configure Redis. So Redis you can configure as a standalone single instance server, or you can have master replica. You can have multiple replicas. And also what you can do is you may want to try this diskless replication. So when you write to master, it does a diskless replication to all the replicas. So it doesn't wait to write to the disk. And your replicas and you configure your replicas to write to the disk in an asynchronous way. So that way, if you lose your master, your replicas, they have the data. So that's how we configure Redis. And I'll give you one example. We have had more than 2,000 node failures on AWS. We have not lost data even once.
So we use Kubernetes, primarily we Redis container. Being in container, can we actually configure master and replica?
For Redis open source, it is still work in progress, but for Redis Enterprise, it is available. So if you are in production, you may want to consider. I'm not trying to sell here. This is an open source summit.
Yeah, we are in production already.
So Redis Enterprise is an option, and we are still trying to get this into open source. It's not there in open source yet.
Yeah, thank you. A great presentation. I'll definitely try out Redis streams, and we'll see if it replaces Kafka or not.
It will. Trust me.
Great presentation, and
Thanks.
I think Redis stream has a lot of potential, and as you mentioned, there are a lot of issues with Kafka and Zookeeper and just getting it going. So quick question. You already mentioned that a lot of people are using Redis in Kubernetes cluster, and that's where there is a limitation of configuring master-slave kind of. So in future, is it work in process, so it's going to come in 3 months, 6 months, or work in progress for like 5 years, 6 years?
Yeah, it is already available in Redis Enterprise. If you are using Kubernetes, I recommend you to go with Redis Enterprise. But open source, we have an open source community, right? We sponsor the project, and open source community works on that. So they are working on it. And I don't have a timeline right now. And what community contributes, that's not in our hands. The community, sometimes it takes its own time. I don't have a timeline how long it takes with the open source community.
And so this structured streaming, does it only support single node Redis instance, or it also has a support for
great question. Yeah,
cluster?
great question. For now, it is Spark Redis is experimental right now, and it supports only single node. But we are working on extending this and making a GA release very soon. For now, it supports only one instance.
So in GA, it's gonna be coming with the cluster support, or
Yes.
still?
Yes, in a couple of months. It is work in progress right now. So we have a team working on that right now.
And is it gonna be something that Redis is working on, or it's?
No, this is Redis Labs working on it.
Okay.
So we are. It's not community. It is our own folks working on it. So that's the thing with open source world, right? You have your own folks working on it. You have control over them, but also you have people in the community that are contributing. You sponsor those projects, but you don't have control over them.
Yeah. So this is one of the reasons we are not moving. By the way, we are very early adopters of Redis streaming. But this is one of the feature that's stopping us from taking it from demo and development to production.
Okay, I'll give that feedback. Thanks for that feedback.
Thank you.
Hi, great presentation.
Thanks.
I'm wondering if when you did those count stars, the aggregate the SQL statements that were counting the total number of dogs, if that would degrade over time as the number of entries increased?
It depends on how big your data frame is. It's not a Redis. Redis is not a bottleneck here. It is the Spark SQL engine. But Spark SQL is known for high performance. So it is very unlikely that you will see a problem.
Would you feel comfortable with doing something like count star over like a huge Redis backend?
Redis is not a problem at all because Redis it's an in-memory database, and we can run more than 1 million ops per second. So even if you do something like count star, you will get a response within a second. It depends on how big your data is, of course, but it's going to be within a second, even if you have million data.
Okay. Thank you.
Sure.
Again, great presentation.
Thanks.
Did you go over schema registry?
I'm sorry?
Schema registry?
Schema for Redis stream, right?
Schema registry, like Confluent Kafka supports schema registry and schema versioning so that you don't confuse data types and schemas within a topic. I guess Redis streams does not support that.
I'm not familiar with that, so I don't know how to answer that. But if you can send me an email, I'll follow up and I'll let you know.
Okay, thanks.
Sure. Yeah. Any question?
So another question was that the streaming support with Redis, I believe that is also sort of in a beta.
Oh, Redis, it's already there. Redis now supports Redis streams.
Is it work in progress or it's already?
No, it's already done. It's all GA.
A few weeks back it wasn't, so just wanted to confirm that.
Okay. If you can give me your contact information, I'll get back to you. It is ready. It should be ready.
What I observed was there was a fork of Redis, and the work was committed on the fork, but not actually on Redis. So just wanted to make sure.
Okay, but it is GA. 5.0 support, Redis 5.0 support is GA'd and it is available.
Yeah, the question was more on Redis.
Okay.
But yeah.
Okay, yeah, Redis, now we are in control of Redis. We have taken over Redis library. So Redis Labs is now supporting Redis library.
That's great to know.
All right, thanks guys. Quick note again for you guys that are still hanging around. There's no session in here for at least the next hour and a half, something like that. The session that was supposed to be here at this time has been moved to 4:30 in 2018. It's a two-part session by Jules Damji. He's great. He's from Databricks. He has a two-part streaming application session. So thanks, guys.